3 minutes ago, metaphorically speaking, the sky stopped being quiet. A second object has appeared. We call it C 2025 V1 Borisov. It has drifted into the same patch of the cosmic theater as that other enigmatic visitor we have been tracking, 3I Atlas. Now, looking at the data flooding into my inbox from colleagues around the world, from amateur astronomers in Japan to the seasoned veterans in Crimea, I feel a familiar sensation. It is the same feeling I had in 2017 when Oumuamua first stumbled through our solar system. It is the feeling that the cosmos is knocking on our door and we are scrambling to find the key. You might be wondering, why should I care about a smudge of light on a telescope image? You have bills to pay, a family to raise, a life to live here on Earth. But let me tell you, this smudge matters. It matters because the story of these objects is the story of our place in the universe. It challenges the comfortable assumption that our solar system is a sealed room, isolated and special. It suggests quite loudly that our backyard is full of traffic, and right now, two strange vehicles are passing in the night, defying the rules of the road. When I speak to my students at Harvard, I often tell them that science is not about confirming what you already know. It is about the courage to embrace what you do not understand. Most of my career has been dedicated to the study of the early universe, black holes, the first stars. But in recent years, my eyes have turned to our immediate neighborhood. Why? Because that is where the evidence is landing. On the night of November 2nd, 2025, Gennady Borisov, a name you should commit to memory, looked up from the Margot Observatory in Crimea. Now, Gennady is not part of a massive government bureaucracy. He is an amateur astronomer, a man who builds his own telescopes. In 2019, he discovered the first clearly interstellar comet, 2I Borisov. And now, 6 years later, with optics he crafted with his own hands, he has found another anomaly. Think about the poetry of that for a moment. Billions of dollars are spent on automated sky surveys, on massive arrays of sensors, yet it was a single human being with a passion for the stars who spotted the intruder first. He saw a faint, unfamiliar blur sliding against the fixed backdrop of stars, moving in a way that main belt asteroids simply do not move. The coordinates went out, the astronomical telegraph started buzzing. And here is where the mystery begins. This object, V1, was bright. It had a condensed coma, that's the fuzzy atmosphere around the core, nearly 30 arcseconds across, but it was missing something essential. It had no tail. If you look at a textbook definition of a comet, it is a dirty snowball. It gets close to the sun, the ice warms up, it sublimates into gas, and dust is dragged out to form a beautiful long tail. We've seen this for centuries. But V1 Borisov, it is refusing to play by these rules. It is a bright, condensed ball of light, unaccompanied by the usual stream of dust. And it is sitting there visually right next to 3I Atlas, another object that has frustrated our models and sparked fierce debate in the scientific community. Is this a coincidence? In science, we are trained to believe in coincidences because they are safe. They don't require us to rewrite physics. But as a detective of the cosmos, I must ask, what are the odds? Let's dive into the geometry, because understanding where these objects are is crucial to understanding what they might be. When we look up at the pre-dawn sky in the constellation of Virgo, we see V1 and 3 are clustered together. To the human eye, or to a two-dimensional image sensor, they look like wingmen flying in formation, but we live in a three-dimensional universe. The data tells us that this is a line of sight alignment. Physically, they are separated by tens of millions of kilometers. V1 is closer to us, crossing upward from below the plane of the solar system. 3I Atlas is further out, riding a hyperbolic escape trajectory, meaning it is leaving us never to return well above the ecliptic. They are like two trains passing on bridges at different altitudes. They are not about to collide. They are not physically holding hands. However, coincidence is a word we use to comfort ourselves when we lack a better theory. Even if they are physically distant, the fact that two anomalous objects, both lacking typical cometary tails, both exhibiting strange brightness profiles, are visible in the same window of sky is striking. It demands our attention. The scientific establishment, and I say this with love for my colleagues, often suffers from a trend-following mentality. If something looks like a rock, we call it a rock. If it looks like a comet, we call it a comet. But what happens when the rock behaves like a rocket? What happens when the comet has no tail? We are seeing reports from Japan, from Ukraine, from the Canary Islands. They all say the same thing: a sharp, compact coma, no tail, and yet the brightness is surging. It brightened nearly 100-fold in invisible light in just days. This is not the behavior of a standard sleepy asteroid waking up. This is something dynamic. So let us explore the safe explanation first, because we must be rigorous. The leading hypothesis for a tailless comet involves the physics of dust. When sunlight hits a dust grain, it exerts a tiny pressure, radiation pressure. If the dust grain is small, like smoke, the sunlight pushes it away easily, forming a tail. But if the dust grains are large, heavy, refractory grains, perhaps made of carbon-rich material or iron, the sunlight isn't strong enough to push them. They linger near the nucleus. They create a dense fog, a coma, but no streamer. This is a plausible explanation for V1. It suggests that this object is old, perhaps stripped of its volatile ices, shedding only heavy, gravel-like material. It's a gravel pile rather than a snowball. But here is where I pause. Here is where I ask you to think outside the box. 3I Atlas also shows this behavior. Two objects, same patch of sky, same unusual physical properties, both defying the dirty snowball model. If you walked into a room and saw two people wearing the exact same, very specific, very rare costume, you wouldn't assume they got dressed in the dark by accident. You would wonder if they were part of the same troop. Could these objects be related in origin? Could they be shards from the same disrupted parent body, separated by eons and vast distances, only to align now, in our view? Or, and I know this makes some of my peers uncomfortable, could they be artificial? I have written extensively about the possibility of extraterrestrial equipment moving through our solar system. When Oumuamua accelerated away from the sun without a tail, I proposed it could be a light sail. Now we have V1 and 3I, and I stress the word, if these were probes or defunct technology from another civilization, how would they look to us? They might look like compact, highly reflective objects. They wouldn't outgas like comets because they aren't made of ice. They might be tumbling. They might be coordinating. The lack of a tail isn't a bug in the theory. It's a feature of an artificial object. A spacecraft doesn't leave a trail of dust unless it's broken. I am not saying they are aliens. I am saying we cannot verify that they are not aliens based on the blurry images we have today. And that brings me to the most frustrating part of this story, the silence of our sensors. We have built the most magnificent eyes in history, the James Webb Space Telescope, the Hubble, the high-resolution imagers on the Mars Reconnaissance Orbiter. And yet, as of this moment, we are relying on backyard astronomers and ground-based observatories fighting through the atmosphere. Why? Because of bureaucracy, because of scheduling, because we treat these anomalies as curiosities rather than urgent priorities. Imagine if the US Air Force saw an unidentified aircraft entering American airspace. Would they file a proposal to take a picture of it in 6 months? No. They would scramble the jets immediately. Yet, when an object enters the solar system, our cosmic airspace, we fill out forms. We wait for peer review. To make matters more complicated, the sun is currently waking up. We are in a period of intense solar activity. Solar storms are hammering the inner solar system. Auroras are visible from North America to Siberia. Usually, this solar wind would tear a comet's tail apart or make it flare up brilliantly, yet V1 and 3, I remain steady. They are stubborn. They are robust. They are ignoring the space weather, just as they are ignoring our textbooks. This stability is data. It tells us these objects are dense. They are holding themselves together against forces that would shred a fluffy snowball. I want to take you back to a moment in my own life that shapes how I see this. I was a young man serving in the Israeli military, working on physics problems that had life or death consequences. There was no room for maybe or let's wait and see. You had to look at the data, no matter how strange, and find the truth. You had to be pragmatic. Today, I apply that same pragmatism to the stars. The pragmatic approach here is not to assume we know what these objects are. It is to gather better data. We need a spectrum, a fingerprint of the light to tell us what V1 is made of. Is it rock? Is it metal? Is it painted with artificial alloys? Preliminary hints suggest carbon-rich material, but carbon-rich covers everything from soot to diamonds to the composite materials of a heat shield. We simply do not know yet. There is a beautiful term in Japanese philosophy, mono no aware. It refers to the pathos of things, the gentle sadness of their passing. These objects, V1 and 3I, are transients. They are here for a brief moment in cosmic time, and then they will be gone. V1 is heading back out. 3I is escaping forever. We have a window of weeks, perhaps a month, to solve this riddle. If we miss it, the evidence vanishes into the dark. What does this mean for you, sitting at home in Ohio, or California, or Texas? Why does the orbit of a rock millions of miles away matter to the price of gas or the future of your children? It matters because it defines our horizon. For most of human history, we looked at the ocean and thought it was the end of the world. Then we built ships. We realized there were other continents, other people. We are currently standing on the cosmic shore of Earth, looking out at the ocean of space. For decades, we assumed the ocean was empty, save for a few rocks and some dust. But now we are seeing driftwood. We are seeing bottles with messages we can't quite read yet. We are realizing the ocean is full. If C 2025 V1 Borisov is just a rock, it teaches us that the solar system is messier and more dynamic than we thought. It teaches us about the formation of planets, the scattering of debris. It is a piece of the puzzle of our origins. But if it is something else, if it is a technological artifact, a probe, a buoy, then it changes everything. It means we are not the only smart kids on the block. It means that our struggles, our wars, our petty differences here on Earth are insignificant compared to the grand community of intelligence that exists out there. I have often said that finding extraterrestrial intelligence would be the greatest mirror humanity could ever look into. It would force us to unite. It would force us to grow up. But even if we ignore the alien question, the behavior of these objects challenges our arrogance. We think we have mapped the solar system. We think we are safe. But V1 appeared out of nowhere. It was found by an amateur. It slipped past the billion-dollar dragnets until it was right on top of us. This is a warning. We need better eyes. We need a dedicated system to monitor our neighborhood, not just for the threats that might hit us, like the asteroid that killed the dinosaurs, but for the opportunities that might teach us. The Galileo project, which I had, is dedicated to this search. We are building new telescopes, writing new software, training AI to look for the things that standard algorithms filter out. Standard algorithms are designed to find what we expect. They are designed to find birds or planes or standard comets. They throw away the outliers. But the truth is always in the outliers. The Nobel Prizes are found in the noise, in the data points that don't fit the curve. V1 Borisov is a data point that does not fit the curve. As we watch these two objects, the twins of Virgo, slide across the sky this month, I want you to feel a sense of wonder. Do not let the technical terms like eccentricity or perihelion scare you off. These are just words we use to describe a dance. Imagine the sheer scale of it, a rock or a machine the size of a city, traveling at speeds we can barely comprehend, silently gliding through the vacuum. It has traveled for thousands, perhaps millions of years to get here. It has passed stars you will never see. It has survived the cold of the interstellar void. And now, for a brief flicker of time, it is reflected in the mirror of a telescope in a backyard in Crimea. We are the witnesses. This is our moment to pay attention. There is a temptation in the scientific community to ridicule what is different. When I suggested Oumuamua might be artificial, the pushback was immense. People were angry. They wanted it to be a rock. They wanted the universe to be boring, predictable. But nature is not boring. Nature is exuberant. Nature is creative. If we decide in advance what we will find, we will never find anything new. If we refuse to look through the telescope because we think we already know what is there, we are no better than the church officials who refused to look through Galileo's telescope 400 years ago. So my challenge to the community and to you is this: keep looking, demand the data, support the search for the unknown. The story of C 2025 V1 Borisov is not over. In the coming weeks, we might see a tail emerge. We might see it fragment. We might see it do something completely unexpected. Or it might fade away into the dark, keeping its secrets. But the very fact that it is here, alongside 3I, Atlas, reminds us that the solar system is not a museum. It is an active, living environment, and we are just beginning to wake up to it. I'll leave you with this thought. I often think about my daughters. I think about the world they will inherit. I want them to live in a world where we are not afraid of the dark, but curious about what lies within it. I want them to know that we are not alone, isolated on a lonely rock, but part of a vast, teeming cosmos that is waiting for us to say hello. The sky is not a ceiling, it is a door. And right now, with V1 and 3I, the universe is knocking. Let's open it, let's look, let's dare to ask the question, what is that? Because in the end, the most exciting phrase in science isn't Eureka, I found it. It's, that's funny, that shouldn't be there.